Let's talk about using springs in visual analysis. Springs are commonly used when you have a support condition where the support is either at an angle or you have a support that's not totally rigid and there's some flexibility. Let's demonstrate that. I'm going to draw a very simple frame here with 3 columns and a couple of beams. And I'm going to take my 2 outside nodes and I'm going to support them as fixed. But my middle node, let's say, is on some sort of a foundation that wants to settle a little bit, and so there's some flexibility in the support. To create a spring, I select the node, use my right mouse button, and select Create Springs from the pop-up. When we look at the dialog that comes up, we see a spring can either be a displacement spring or a rotational spring. You can think of a rotational spring as like a watch spring. We have the ability to set the spring to be infinite, or if not, then its stiffness value. I'm going to take the default here that it's not infinite, and it has a stiffness of 12 kips per foot, which is to say if that node were to displace a foot, the reaction would be 12 kips. The direction can be specified, and by default here it's in the -y direction, or direction number 0, -1, 0. If I select OK, I see a spring gets created. That spring, like other objects, is selectable, and when you do that, you see over in the Project Manager the ability to enter or edit the properties of the spring. If we quickly look at the results for this structure in its own weight, we see that indeed that middle node has moved down or support settled. And if we click on the spring, we can look over here in the results and see that it is about 82 pounds is the reaction on the spring. So that's a way to create a manual spring and to have it model something as a spring support. Let's look at another example here. I'm going to go ahead and select everything and delete them and create a new model where I have an inclined member. And I'm going to draw this inclined member on a 1-to-1 angle. And then I'm going to draw a horizontal member. And let's say that's it for my structure. Over here on the right, I'm going to set this node to be fixed. But down at the beginning of the structure here at the first node, I want to put on a support that can only have a support parallel to the member. To do that, I'm going to use an inclined spring. So I'm going to select that node, right mouse button, and select Create Spring Support. When I do that, I'm going to go ahead and take all the defaults again, that it's not infinite, 12 kips per foot, but its direction now is important. I'm going to select Other, and by default, the direction is -√2/2x, -√2/2y. Well, that's right along my member, pointing away from the node. So if I click OK, we'll see I have created this inclined spring. And if I look at my results now, I can see that I'm going to have a reaction in this spring by selecting it, and the inspector is telling me that I have about 362 pounds for its reaction. So that would be a way to create an inclined support. The final thing I'd like to demonstrate with springs is the ability to have soil springs created for you automatically. To do that, I'm going to go ahead and delete my structure again. This time go to the Create Tree, and I'm going to look under the Plates and Tanks objects and select a cylindrical dish. This is going to allow me to create a circular mesh. I'll take an outer radius of 20 feet and inner radius of 0, so it's going to be solid. Let's use 5 in the radial direction, 10 in the circumference direction, and we'll make them out of concrete and 6 inches thick. So if I hit generate, I'll get a generated mesh. Now, one of the things that's built into visual analysis is that if you select a plate, you can generate springs at its nodes to represent soil. So if I select these nodes, I can take a look at the Structure tab, and there's an option under Create to generate spring supports or soil springs. So I'm going to select that, and now I have a dialog that lets me specify a subgrade modulus. In this case, the units are kips per cubic feet. The contact face is the -z face. Well, we have to be careful here because we don't know what the z direction is of our plate, so I don't know which is the -z face. So I'm going to cancel at this point, go back to my model, filter, look at plate details, and I'm going to turn on the local axes. So if I do that, I click on local axes, and now I'm going to rotate my plate a little bit, and to see that my z-axis is actually pointing down in the negative z direction for all those plates. So that tells me my soil is really on the positive Z face. So I'm going to reselect the plates, right mouse button this time, and use Generate Soil Springs. Same dialog comes up. I'll use the subgrade modulus, but my contact face now better be the plus Z face, which is the soil side. And when I do that, I see I get a bunch of springs generated that represent the contact for the soil. If I click on one of those springs, I also want to point out an interesting thing. Its action is set up to be compression only. That means that if this node were to lift up, that spring would be basically removed as it would happen if it removed from the contact of the soil. So soil springs then are very handy to model contact situations where the soil is in contact with the plate.